Hi, good morning. This particular episode that we're going to do right now is a basic getting started on programming. First thing we're going to need, obviously, is a few things like what we're going to operate or machine. We have a little basic code book for your quick reference guide. We have the print, and we have a program that I'm going to discuss. And like I said, we're just going to start the beginning, get it going, and how you should approach this, and we're going to show you how to end it. It's a little easier. The ending and the beginning are pretty much similar almost to any job that you do. And a good start with notes is very, very important. Very important. Okay, to start with, we have a part. It's a lathe part. It came off a lathe and it's round and such. But to complete the part, according to our methods, is we need to machine this flat, as you can see, and we're going to drill and tap some holes in this to dimensions on the print. So on the print, they're showing this flat bottom to be 615 thousandths. They give you a center distance on the hole and what size thread to do. They're going to do a 632, approximately 350 thousandths deep, and in 2 places. Okay, so to get started, basically how you would start this program is, number one, you're going to give it a number, and we're going to use a percent, which is required in all programs to start with a percent, and we end our program in a percent. The next thing that we put in is the letter O, which tells the machine and the computer and the software that a program is coming. It is the first and only time you're going to use this letter O in this program. The number after this is our a given number that we could. In this particular case, it's 03862, what have you. At this point, everything thereafter are going to be notes. Very good notes is important. You want to have notes in the beginning so that you can do this again if you have to. It's also a good footing to do another job that's different. Notes will describe how that one does. Now, in here, we're telling this particular job in the notes that we're using an output drum, 4 pieces, and a vise and such. Now we're going to have our tool list. The first part that we want to really go over here is our tool list. Very important. We have decided that we're going to use 5 tools. A 1/2-inch end mill, a 1/4-inch carbide countersink, a 3/16 spot drill, a number 35 stub drill, and a 632 tap. Okay, the way we write our tool list is, obviously, all notes are in parentheses, starting and beginning with the parentheses on the same line. It will default if you do not do that. So we describe tool 1, T1, 1/2-inch, 4-fluted stubby carbide end mill. Fine. And we tell it also, which is very helpful, how far to put the end mill in the tool holder. We're saying 7/8 of an inch out. Okay, the next tool would be T2, 1/4-inch by 90 carbide countersink. Again, sticking it out about 7/8. These are notes. Our tool 3 is going to be a spot drill, 3/16 by 90, again 7/8 extension. T4 is a stub drill, and it's 110 thousandths in diameter, and we have it sticking out approximately 1.5 inches. These distance of extension in the tool holder are very important because you don't want to have a situation where the tool holder either touches or gets too close to the work. Okay. The last tool, T5, is going to be our threading tool, or our tap, 632 GH2 gun tap, or plug tap, and we have its extension sticking out about 1.25 inches. These are our notes. Now, the next part of our notes is, how do you hold these parts? And we have a description of that in our notes to set up an operation. To hold it, we're going to use a double-ended vise. The second note that we have here are We're going to use the large diameter to locate our fixture on, our parts on. The third important note is where we're going to grab our absolute 0, reference point. They're telling us to do the top of the part. We want to use the top left of the jaw for the bore, and the fixture offset or the work offset is going to be G54. And according to this, they also want to use a G55. But they're all in the notes as to what we're going to be using. And this information will be seated in the program as we write our program. Also, another nice thing is in the notes at the very end is the time with respect to how long it takes to do the part, and the setup time, the time that it takes us to actually get this job running once it's running. Now, I'm going to start off with our basic G code. And this is definite programming now, the very beginning of the program. This is what the machine is going to respond to. Remember, all our notes is information for us, basically. The machine sees it, it's not going to do anything. But at this point, the program, it's going to start to function. We like to show G00, G40, G80, G90. There could be more G codes up there. And in G codes, you can pretty much put as many G codes on the same line as possible. But remember this, you can only put one M code per line. Only one M code. The G codes above, this is a rapid, a G00, telling the machine to go as fast as it can. G40, it just is canceling of tool radius comp. It's radius compensation, cancel. G80s is drilling and all kinds of codes to help it to drill different ways, and it cancels all those cycles. G90 is just absolute. Tells the machine we're dealing with absolute. The next line, which is telling us what tool we're going to use, obviously we want to use T1. Our nice notes and our programming numerically works this way. And we're using T1, tool 1. MO6 is representative to a tool change. The next line, we're going to have a spindle. The machine needs to know how fast and what direction. We're going 2800 spindle, and we're going in an MO3 direction, which is clockwise. The next M code, like I said before, can only do one M code per line. MO8 is cooling on. The next line is a G55. It's telling you to read the work offset sheet and to go to a position. The next line, G43 line, these machines are very nice. They like to make sure that the machine and the tool in the spindle are the same. So this line is a check. G43, H01 should line up with T1. H1 and T1 must be together. And it also gives a Z move, which is a downward move to 100 thousandths above the part. It can be there or not be there. You can put it on a separate line if you choose. The next line is a machining line, and it's telling it to machine down to a -605. And remember, if you look at our print, it's saying 615. Well, this is a roughing pass. It goes and does that, it comes back over, comes up, and comes back down, and now it's going to the 615 Z move down to produce that dimension, 615, 615. Now, at this particular point, we're going to maybe do another part. It's giving a position to continue machining. We can go into this another time, but these are your basic machining operations. And we're going to go to, we're looking to continue on. We have our second tool, T2, which we described in our notes as carbide countersink. Then we're going to come down to T3, T4, and then T5 is going to do the final threading. To end our program, we would like to end the program with a G53Y0Z0. That actually lifts the spindle up to its tool change area, which is out of the way, and it's going to also move to you and center so you can actually work on the vise, and then it's going to end the program.